computing. So again, what is the problem in fog computing? Because fog is coined by the Cisco, and fog will have certain issues related to the security, and it's a distributed system. But right now in noise computing, everything on your hand, you can implement your security issue, complexity will decrease, and computation will be in your hand. And for time sensitive applications, the response will you may get the immediate response. So welcome you all this session 2A. Now we have a 7. Just a minute. I think we have a 7 papers in this session.
These are on the screen, sir.
Yeah. Okay. So you just a minute. So each presenter will get 20 minutes for the presentation and 3 minutes of question answers. First presenter is performance evaluation of distributed ledger technology of IoT data registry. Who is presenting? Is the presenter is there?
I think, yes, he is there.
Yeah, I think Moha Madreja.
I have unmuted you, Mohammed.
Hello, yes, I'm Mohammed Reza.
Yeah, I am unsharing my screen, and you can start sharing your screen for the presentation.
Sure,
Go ahead, please.
Mohammed, you have a 12 minutes for presentation, and 3 after that we have 3 minutes for discussion. Is that fine?
Thank you. All right.
Yeah.
Okay. Okay, anybody can see my screen?
Yes, we can.
All right, I'm Mohammed Reza, Reza Rovesi. I am PhD student in Polytechnic Montreal, and today I'm gonna to talk about my current research regarding distributed ledger technologies for IoT registry. It's a comparative study of different blockchain platforms to study how performant are some of our distributed ledger technology that we have chosen for this research. So why IoT is important and why we need to secure our data, because it is estimated by 2025 that we are going to have 27 billion IoT connections, and we will have 3 trillion revenue forecast and 2 zettabytes of data, which means that we have a lot of data which are produced by IoT smart devices, and we need to secure. And if we don't do so, we might lose a lot of money in that section and industry. So here I'm going to talk about the vulnerability of IoT devices. An example could be a smart home that are all the data are the devices usually vulnerable to attacks. Just imagine we have a security camera that intruder can access, or a smart gate or a smart door that the intruder can access to the system and can enter to the house, or a smart thermostat. So we need to make sure that our privacy and security for the residents in smart home or smart applications, generally IoT application, will not be jeopardized when the attackers are trying to enter to the system. So the main concern that we are going to follow are integrity, confidentiality, and availability. It means that our data are secure, and only us who can be access to the data anytime, and it will be available. So one of the solutions that is proposed is blockchain. And blockchain is a large scale, distributed, immutable, and decentralized platform that is supposed to guarantee security. So although blockchain is a very secure because of the different reasons that I will talk in my next slide, but it is very expensive because it has computations load and energy consumption. So when we are going to adopt our system with a blockchain for IoT application, which are real-time and resource constrained devices, we might have some performance degradation and cost. So I'm gonna to choose a different blockchain platform in this study to see how expensive are using this blockchain platform when we are going to integrate with IoT applications. So I'm going to briefly talk about blockchain. The 3 main characteristics of blockchain are decentralization, transparency, and immutability. And here on the right side is the example of proof of work that as an example, that is in a peer-to-peer network of blockchain that are all nodes over there, and there is an attacker who is gonna to change the block 74 here, and when we are all working on 91's block, and when the attacker is going to change the data, because all the data are linked together as provided in the left picture, that all the hash of the blocks are connected together. So if you change one block, you have to change all other blocks. So for this example, when the attacker is going to change the 74th block, they have to change all other blocks to till 91, which takes a lot of time and energy and computation load. So it makes the blockchain tamper-proof. And here is an example of why blockchain is tamper-proof. The right side is the example of proof of works that the participant of the networks all have to find a hash. So they are using energy and time to confirm a block in the network. So two main characteristics are consensus protocol, which means that majority has to agree to the data to be added or removed. And there's also cryptographic fingerprint. It's called hash. It takes a lot of computing power and energy to generate a block initially. So I'm going to talk about my study. So in this study, I have chosen 4 blockchain platforms, including Hyperledger Satus, Hyperledger Fabric, Hyperledger Barrow, and BigchainDB. I have also used to try to include a non-blockchain database. It's called MongoDB without any security. So I wanted to compare from to when we are, so now and traditionally we are all using NoSQL or SQL databases without any blockchain distributed databases, but I wanted to compare that how expensive to migrate from non-blockchain system to blockchain system. And my study of IoT application, I have used, I have designed a workload generator. It is a smart home, could be a smart building, and it has a different rooms in the system, and there are different sensors and controller, and all are sending the data to IoT gateway. Each blockchain platform that I have chosen are using different consensus algorithms. For Hyperledger Satus, it is using proof of lapse time. For Hyperledger Fabric, it is using a consensus of graph. For Barrow, it's proof of stake, and BigchainDB is Tendermint, which is part of practical Byzantine fault tolerance. So each of these consensus algorithm will impose some performance degradation. So I want to measure what is the difference of using different blockchain platform with different consensus protocol. And another thing is to mention that some platforms such as Satus are supporting parallel transaction, which for to be submitted in the blockchain system, whereas Hyperledger Fabric does not support that. So that's why I decided to choose different consensus protocol with a different blockchain platform, which are famous by many researchers, to see what's the difference when we are going to store our data in these blockchain platforms. Here is my simulation lab, and so in my study, I have used Docker container for the simulation of the IoT devices. I have used the HA proxy as a load balancer. I have used Nginx as a web server. I have used C-Advisor for monitoring of the data, for monitoring the resource consumption, including CPU and memory. Each container will be, for each container I have installed Flask to run the Python code for simulation of the devices. And I have also used the Python code to measure the delay. So when the data are being sent from the container of, for example, the camera, I measure the response time. So this is the experimental setup. This is the distribution of my 5 sensors here. I have used 3 nodes in the Amazon EC2, which has 4 GB of RAM. In total, because I wanted to saturate the network, I have used 10,000 to 16,000 over the time. If you see here, there are 5 sensors that over the 26 minutes are being distributed. Sometimes I reduce them, and sometimes I am going to increase them to see if I increase or decrease what is the effect to the system. Here is the result of the response time of the 4 blockchain platforms. So as you see here, the Hyperledger Borrow is having the worst case scenario. It is very slow. It's over 2200 milliseconds, whereas the best solution in this study is Hyperledger Stratus. So I feel that one of the main reason that Hyperledger Stratus is performing better than Borrow could be the consensus protocol. The Stratus is using proof of elapsed time which is designed by Intel and using the Intel CPU for the consensus platform. And but it seems that BigChain DB and Hyperledger are almost the same, but Hyperledger Fabric is slightly better than Borrow. As you see, the response time could be by average is better. And and I also compared my MongoDB as a baseline, and it seems that the MongoDB is very fast still, and because there is no block-ified distributed system, and so it is very normal, and it is showing us that how expensive is it to go to non-blockchain to blockchain. Here is also the comparison between blockchain platform in terms of CPU consumption. And as you see here, that the Hyperledger Stratus has the best. It's about 55% of CPU utilization, whereas the Hyperledger Borrow is having around 84.
Sorry for interruption. Dear presenter, you have last 2 minutes. Please conclude your presentation.
Thank you, sure. Yeah, so and the Borrow is the worst case scenario, and MongoDB is the best one in terms of CPU utilization. The same as memory, the Stratus is performing the best one, and the Borrow is the worst case scenario. And here is the effect of increasing and decreasing the IoT applications, IoT devices. As you see, the Borrow is still the worst case scenario, and it has a very much fluctuation, whereas the Stratus is the best one. It has the less minimum fluctuations in the system when I am increasing and decreasing the number of sensors over the time in terms of response time. So to conclusion, it seems that blockchain is significantly slower, and they consume much more resource than non-blockchain distributed database. We can assume that this difference could be acceptable given the improved security. As you saw before, this Hyperledger is the most expensive blockchain solution, and Hyperledger Stratus seems to be the best in terms of research utilization and performance, incomparable to best option to Fabric and BigChain. So in my study, I believe that one of the reasons that the blockchain is slow is that consensus protocol, which plays a role in this in a study. So in my study, proof of elapsed time is a winner with in Hyperledger Stratus, and the proof of stakes is the slowest blockchain platform in Borrow. And in my future study, I'm planning to study the different consensus protocol in one blockchain platform to make sure that it is really consensus which is making delay on the system. And I would like to use real IoT devices on my experiment to make it more realistic. Thank you for your attention, and let me know if you have any questions.
Hello.
Yes.
Yes, Dr. Dharam.
Yeah.
Any questions from the audience?
Yeah, I think there is no question, but can I ask one question?
Yes.
Sure, please go ahead.
Yeah, so it's a nice presentation, and you know, now it's a trade-off between the security and the time response. So I think your proposed system definitely increase the time response. My question is, sometimes, you know, the security is the main issue, like digital currency or some other applications, and blockchain is essential to consess or update the security information somewhere and changes. What mechanism you are using your ledger for the security purpose?
So I have used the default platforms that are available in the open source GitHub. So I have used different blockchain platforms that are available for Satus, BigchainDB, and Fabric, and Satus. I have used the original default configuration of this platform, and I've installed all three in the Amazon EC2 and stressed the system of this platform using the simulated IT applications that I sent my data to be stored in these 4 blockchain solutions. And I have used the default configuration of the provided platforms, and I did not change the default configuration to measure the main provided platforms in my comparison study.
So, Mohammad Reza, again, the question is related to the security. Can we implement the cloud security in your mechanism?
So the security of this blockchain are using the consensus protocols that, yes, so we can apply the blockchain, the cloud. And but as you saw here, we are going to have a slower response time, but it seems that it is to be acceptable so far. If we, for example, apply the Hyperledger status for in a cloud, and the response time of storing the data and getting the result is around 700 milliseconds. So I guess that it is acceptable to have a better security, which Southwest is using proof of elapsed times. But for sure, I'm planning to study the security of each consensus protocol. As I said, each of blockchain platform are providing different security, but I want to also in depth do the extensive study of what is the difference.
Okay,
of
thank you. I think we are running behind the time. Thank you.
Okay, sure. Thank you. Thanks for your time.
Next presenter.
The paper title is Prototype to Perform Audit in Social Networks to Determine Cyberbullying. Moises, is he here from Ecuador? Next 2 papers are from the same author, so I don't hope he is here. So we will not wait. If he'll come at a later stage, we will just shift the presentation. So I am directly moving on to the 4th presentation. Sir, Moises, are you there? No. A survey of intrusion detection system IDS using OpenStack private cloud. Himali Gajjar from India.
Yes, I'm here.
Okay, Himali, you can share your presentation and start presenting your work.
Okay. Hello everyone. Today I'm going to present a survey of intrusion detection system using OpenStack private cloud. My name is Himali Gajjar. Now let's first have a look what is cloud computing. So cloud computing gives delivery of different services through the internet. This gives the service of data storage, servers, database, networking, and software. So here I have listed cloud provider companies, so like Amazon, Microsoft, IBM, Google, Salesforce, and so on. Now let's have a look what is IDS. So intrusion detection system help us to monitor network or a system for unusual behavior, malicious activity, policy violation, and so on. So by developing intrusion detection system, administration or the collected centrally, the security information and event management can gather the information of unusual behavior or malicious activity. So that can be recorded on one device, and by that that person can analyze and detect the intruder. So there are different type of IDS are available, which is host intrusion detection system, which collects the data via endpoint security management system, then network intrusion detection system, then application intrusion detection system. So here I have focused on network intrusion detection system. So here are the main company which were victim of which were victim by attackers. So Yahoo was attacked in 2014, and a crucial databases like name, date of birth and telephone numbers are theft by attackers, and Marriott was also attacked, and the payment information is very crucial, right? So if we lost our payment information, there is a huge financial crime, right? So to save this theft, we can it is necessary to develop intrusion detection system. So these are the type of intrusion detection system, as I have also explained. And there are different type of techniques available, that is signature based, anomaly based, and hybrid. And this is the classification of IDS. It can be based on architecture, decision making, locality, based on response time, and based on detection method. So let's first have a look on what is signature based algorithm. So signature based algorithm detects the attack by looking for a specific pattern. The patterns which are already attacked is saved in a database, and whichever the pattern is coming, which will be matched by that saved pattern, and by that the machine can be detect, or admin can be detect, that this is the malicious activity or the unusual behavior or not. So this is the signature based algorithm. Now what is anomaly based algorithm? So anomaly based algorithm builds a model of normal behavior and automatic detects the significant deviation from it, and that includes application of clustering, outlier analysis, classification algorithm, statistical approaches. Now I have used I have survey the papers which used OpenStack. So it is a private cloud provider, as Amazon is the public cloud provider. OpenStack is a private cloud provider, and it gives data center, dashboard, networking service. Like you can see, OpenStack is providing block service as a Snyder, then Horizon as a dashboard, Glance as an image service, and so on. So I have a survey of different papers. In the first paper, researcher analyzed the result and the performance of the network intrusion detection system to improve by detection real-time alert successfully. The real-time alert is useful for private cloud admin to become aware of any possible classified attack. And they have used a performance metric and evaluated by classification, detection, false positive, and precision tree. And in the summary, they have declared that UDP flooding packet did not give significant impact on CPU and memory usage, where it gives the significant for network traffic, and that could be failure, communication failure between host and VM. In the second paper, they have used a string pattern and divided in sub-level of identification and then stored as a history. They have used signature-based intrusion detection system, and the result shows it's more effective than traditional. So the result based on timing and dealing of deadline of intrusion during light and heavy loads. Then let's have a look on paper 6. They have developed cloud distributed denial of service attack protection. So that is CDAP, which is a virtual firewall, and it filters attack packet and improve availability by threat detection and attack mitigation to cloud denial, distributed denial of service attack protection nodes, and redirect malicious user to dumb network. The proposed architecture is less cost communication consuming because server is still available to client, does not shut down the server, and so it is available to client. And the proposed scheme at the data center shows efficiency in identifying attack at the initial stage of distributed denial of service, launch and eliminating immediately. In the paper 7, it indicate clustering and KDD achieved accuracy of detection rate in novel anomaly, which is NEC, to detect high level of detection rate and false positive rate. An unsupervised anomaly plays an important role here. So this is a proper for problem solving and anomaly detection, which can be labeled or unlabeled data set. So by KDD 2019 data set, we can verify this, and the pretended structure will convert all in the form of normalized data. So, and our, yeah, so let's have a look on paper number 15. They have mainly focused on anomaly based IDS and shows changes in processing large number of requests and obtain data without attack we solved, right? So it is also try to achieve accuracy compared to method which is used to represent behavior. So by doing this, researcher shows the n-gram data modeling of web requests are promising to give accurate result to detect attack with a high detection rate and achieve very low false positive rate. Next, paper number 16, they have developed signature-based intrusion detection system to find intrusion detection in network system and virtual machine instances of the cloud. This shows all traffic passed through network provider as well as self-service provider network structure in OpenStack private cloud. It majorly focuses on memory and CPU. So by the observation, we can say that paper number 15 only use anomaly based detection, and paper number 16 only uses signature based algorithm. So by combining this both algorithm, we can achieve a good CPU performance and a higher memory rate. And paper number 17, we can see that they have got the proper CPU rate, but there is a need to improve performance and scalability. And in paper number 9, we can paper number 1, we can see there is a communication failure between host and VM. So I want to develop an algorithm like architecture. By that I can reduce the communication failure between host and VM and improve CPU and memory performance. So there is a huge need to develop intrusion detection system nowadays. So in the future work, I would like to use a combination of signature based and anomaly based algorithm, as I say, to reduce false alarm rate with greater CPU performance and reduce communication cost. So this is the reference I have added. Thank you.
Thank you very much. I think over to you, Dr. Dharam Singh, for your comment.
Yeah, is there any questions from audience? No? So Himali, it's nice presentation. And the survey is very useful for the IDS research. There is a small query about the IDS. Once we received a lot of data using different technologies. So is there any, did you did something on how do we analysis the gathered data?
Yeah, so I
because
have
once we,
okay, sorry.
Yeah, you can go ahead.
Yeah, so I have read some paper in that they have used they can use a data set which can able to accept large number of data set. So by that we can use and improve the performance of CPU and memory usage.
Yeah, so these days we are using a different classifiers for this purpose based on artificial intelligence. Are you working on OpenStack?
Yes, OpenStack.
So which classifier you are using for OpenStack?
Actually, I have not used OpenStack. Like I have just created instance and all. So there is a need to go through OpenStack yet.
Oh,
I have
okay,
just
okay.
did survey on intrusion
Alright.
detection using
Yeah.
OpenStack.
Yeah. Sometimes we say that two signature-based anomaly algorithm you need to combine. But you see, this is the hybrid algorithm, and hybrid algorithm response time is more. Sometimes, response time will increase. And for time-sensitive applications, that hybrid algorithm may not be work. So I think it's a good survey, but yeah, you have to, if you want to select some hybrid things, then you have to do more survey related to the response time or real-time application. Thank you.
Okay, thank you.
Yeah. Next.
Thank you
Next
very much.
presenter.
And the next presentation is by Najmus Saqib Watson. So, is the author here correlation analysis of demographic factors on low birth weight and prediction modeling using machine learning techniques? Please ping us if you are available in the meeting, or else we will move on to the next one. I don't think he is here. So we are moving to the next one, that is error-free communication in NB IoT using ECC approach. Bhavna are ready. Is Bhavna here?
Yes, sir, I am here.
Okay, please share your presentation.
Yes. Thank you. Good evening, everyone. So the topic is error-free communication in NB-IoT using ECC approach. So firstly, as we all know what IoT is, it refers to a system of interrelated, interconnected objects that are able to collect and transfer data over a wireless network without human intervention. So we know how much IoT has an impact on human living now. It ensures and elevates the quality of human living. So this continuous evolution has always improved the kind of human activities and the kind of daily activities like smart cities, smart hospitals, highways, smart factories, smart transports, and all. So one of the major evolved version of IoT is the narrowband IoT. So where narrowband IoT is a thinner version of the IoT which can be deployed in various fields like we saw. So the bandwidth is 200 kilohertz and it can be deployed in guard bands of LTE and GSM, standalone bands of microwave frequencies, which is about 700 to 800 megahertz. And it uses half or full duplex communication systems. One major advantage of it is a low power wide area network. So what this helps in improving the power consumption of devices, so the battery life is longer, and also it helps in the improving the system capability and the spectrum efficiency. So it also provides cost effective services not just in urban areas but also in rural areas. So seeing all these advantages, there are obviously the other side of the coin, so we'll have some disadvantages as well. So some of the disadvantages are going to be like there are going to be signal attenuation. So there's going to be inherent noise, distortion, attenuation, dispersion. So because of all such things, there is for sure some data issues that will occur when there is transmission of data. So we have come up with an arrangement of BCH module within the NB-IoT architecture. So this ECC module will help us to give a better data integrity and security for the data. So this what this structure basically is that there is a server side and a client side. So the server side is placed in where we get the data from, the parameters are got from, and the main function initiates the interface function, and interfaces in turn invokes the server program. The data instead of physical layer is rerouted via the MAC layer. The commands inputted via the keyboard sets up the configuration for data sensing and the transfer. So once the configuration messages are stored in the device server, we have, so this storage is nothing but a memory. So this memory can be either ECC or non-ECC. So it can be either error correcting or non-error correcting, and registered or unbuffered. So here we are considering a registered ECC module type with NAND flash memory. So once this whole operation is done on the server side, the app performs the specific action of data sensing, and this data is then sent to the socket via internet through the to the client side. So before this sending, the data is being properly encoded and then sent to the client side, where the data is again supposed to be decoded to get back what the original message was. So concentrating more on this ECC encoder decoder, this is the block diagram where we have the four steps of encoder, where we get the primitive, minimal, and generator polynomial along with the construction of systolic array. And once the data is stored, we go into the BCH decoder, where we have again four steps. That's Galois field, syndrome calculation, coefficients of error locator polynomial using the PGZ algorithm, and roots of error locator polynomial. So the encoder which we are using here is the tree-type systolic array BCH encoder. And here the numbers which you can see is n, k, t, where n value is 8191, m is 8139, and t is 4. So here where you can see that the n and k values are actually being generated from the m value being considered as 30. So here, for example, we have considered a main area of 2448 bits and 128 bytes of spare area. So when we consider the 2048 bytes being divided into chunks, this chunks is completely optional. However, the division can happen, but we have chosen it to be 512 bytes. So which comes up to 2 part 12 bits. But to actually accommodate the parity bits, we have gone to 2 part 13. So keeping m as 13, we get all the n, k values as such. And so the not getting into the complete mathematical form of this. So as the normal polynomials, generator primitive polynomials for Galois field 2 par m. So being considering m is 13, we get these, which are standardized equations now. And we get the minimal polynomial, we generate the minimal polynomials from the primitive polynomials. And then for the generator polynomial, we take the LCM of these minimal polynomials. One good thing here is that we can reduce the number of computations by using the concept of the conjugate roots of g of x having the same minimal polynomials. So the number of terms reduced to half of it. So this is the systolic array structure that we are using, where we can get the parity bits that are being joined along with the message bits. So the programming of this module is done in this format. Whatever has been explained till now, the same thing has been put in a proper flowchart here. So this is the proper ECC, the encoder module, which is being actually programmed in Xilinx in VHDL coding. So next is the once we have the encoded message, we have the BCH decoder, where we get the Galois field roots generation. So roots are represented in form of beta. So here, as we can see, from beta par 0 till beta par m minus 1, we have the roots in where in the positions of the numbers we have the ones, and once we reach beta par 13, we have the equation of using the primitive polynomial, we get the normal equation, the values beyond beta par m minus 1. So once these roots have been generated, we go to the syndrome calculation. The syndrome is actually an indication if there is an error present in the received code words or not. So using this standard equation of syndrome calculation, we along with the roots generated in the previous stage, we get the syndromes. And here, because the syndrome limit is 2t minus 1, so because we are considering a 4-bit error correction, it will be I is going to be till 7, so we'll have S1 to S7 here. So once the syndrome is calculated, we go to the coefficients of error locator polynomial. using the PGZ algorithm, which is the Peterson-Gorenstein-Zeller algorithm. So these are the standard equations that have been generated for 4-bit error correction. So substituting the syndrome values got from the previous stage, we get these lambda values, which are the coefficients of the error locator polynomial mentioned here. Once these are got, we go to the roots of the error locator polynomial. This is the error locator polynomial. So once we derive the syndrome, the all the roots and the lambda values, we calculate the roots of the polynomial. So what this does is it indicates the inverse of the error location. So inverse of the error location is that to get the actual error location, you will have to just do n minus the value which we have derived, got at the final result. So the same thing. So this is how the 4 steps are, and the same. This is used as a flowchart for developing the decoder module in our Xilinx VHDL coding. So the results and waveforms are just a discussion. So here we have the simulated waveform just for an example of a BCH decoder. So for this message, the parity bits will be as shown here in decimal form. And for the performance comparison, because we are using a parallel BCH encoder, how it is better than a serial BCH encoder? It is that the number of cycles, the time we save, because if it is suppose we have a 32-bit data, it would take 32 cycles in a serial BCH encoder, but in a parallel and a BCH encoder, when it is 32 bits, we can it can be done in 4 cycles. So it is 8 times faster than a serial BCH encoder.
Sorry for interruption. There is only 2 minutes left. Please conclude your presentation.
Yeah, sure. So this is the BCH decoder. As I already said, when syndrome and coefficients are 0, it indicates that there are no errors in the received code word. And when we have some values, it indicates that there is some error. Suppose here we can see 8127. So 8127, the error location will be 64. That's 8191 minus that. So that will be the 63rd bit being an error. So the conclusion is that NB-IoT already being a cost-effective, reliable solution, when it can be culminated along with ECC, the pure electronics concept, that time it can actually improve the data security and data integrity as well. So there can be error-free transmission of data. So the future work for us here is that adaptability to the number of errors being corrected. So the T value can be changed as per the requirement is what is the future study. So yeah, thank you so much. Thank you for your patience.
Thank you for your presentation, and over to you, Dr. Singh. Dr. Singh, are you able to hear me? I think there is some network issues with the chair. Dr. Singh, any questions from your end?
Now it's fine.
Okay. So,
yeah, so it was muted.
okay, no problem. It's fine.
So Bhavana, thank you for presentations. Just suggestions that you have not included any references in your study.
Yes,
For any presentations, you need to include some references.
Oh, sure.
Second, my question is, this narrowband IoT, where is the specific applications for that NB IoT?
So it is in different fields of communication. Like suppose in terms, as I mentioned, it can be used in the same applications as of IoT, but it is nothing but in a narrowband form. So in terms of
narrowband, of course, we do not have a sufficient bandwidth. So narrowband means the bandwidth is less than 5 gigahertz. Is am right?
Yes. Yes.
And generally Wi-Fi we have a 5 gigahertz. So I think this particular NB-IoT these days and present scenarios can be used for the satellite mobile communication maybe.
Yes, sir. So,
Because we have a lot of IoT and previous presentation presented that the IoT in 2025 that we have the IoT and the data big data will be generated due to the IoT. So IoT is the main devices that everybody will use. So in that case, is that NB narrowband IoT can be used?
So yes, even I haven't deeply done my study on complete NB-IoT. So as you mentioned, it can be used in satellite communication. So using the concept of ECC in NB-IoT, so that the main purpose here was for data integrity. So what our main whole purpose of this paper was only to the correction of errors and to make sure the error-free data transmission was possible in terms of any kind of communication as such. So even I'll have to do my further studies on that. So,
Okay, which simulator you use for your study?
Xilinx ISC, sir.
Okay, thank you,
Thank you.
Mom.
Thank you very much. Moving on to the next presentation. There are two presentations left, and I think the authors are there, but we will consider your presentation once this last presentation is over. So I invite Urmil Shroff, Flavor and enhancement to the existing auto rickshaw system in India.
Yes, hi. Hello.
Yeah, Urmil. You can see your presentation now.
Yeah. So I have my team members also with me, Priyansh Ramnani and Vinay Kolvankar. So if you could please unmute them as well.
Yes, we will.
Yeah, thank you. So good evening, everyone. My name is Urmil Shroff, and along with my team members Priyansh Ramnani and Vinay Kolvankar, we'd like to present to you Flavor, an enhancement to the existing auto rickshaw system in India. So in the current scenario, the auto rickshaw system in India is very mismanaged in terms of the demand and supply. The probability of getting an auto rickshaw is extremely low when you really need one. And so our system aims to enhance and bridge that gap between drivers and riders with the help of technology. So the three main problems that we face today are the mismanagement of auto rickshaw demand and supply, drivers being unhappy with the alternative systems such as Ola and Uber, and riders not being able to carpool freely and easily with whoever they want. So we took a market survey of around 50 drivers in the Vile Parle area of Mumbai. Based on this, we found out that 60% of the drivers use a smartphone. However, 77% of them prefer not to use services such as Ola or Uber. We also surveyed about 160 riders and found out that nearly 50% of them find it difficult or extremely difficult to catch an auto rickshaw to a destination where they wish to go. And 80% of them say that until they find an auto rickshaw, they just keep trying or they start walking it. Whereas only 15% of these people actually book an Uber or an Ola. So as a brief comparison between Flivver and the alternative systems like Uber, Ola, and BlaBlaCar, Flivver does not charge drivers with any sort of commission, whereas a system such as Uber, they charge around 20 to 30% commission, which the drivers need to pay to the parent company. Also with Flivver, there are no additional charges for riders besides the regular metered auto rickshaw fare. Whereas in Uber, Ola, the prices depend and fluctuate based on the demand at the given time and area. And also in BlaBlaCar, the driver of the car himself decides the prices. Flivver is also extremely privacy focused without requiring any login. And there are also no cancellation charges. as opposed to Uber and Ola and BlaBlaCar, which may charge you if you cancel a ride. So my friend Vinay will explain the flow of the rider app.
Hello, everyone. So based on the market survey, we decided to make two apps. One app would be for the driver and one for the rider. The primary goal of both the apps is to show the demand density to the drivers in form of hotspots and markers. So on the rider app, the rider can first mark his location and enter the destination that he wants to go to. Then he can either wait for other riders to mark the location, which would create a hotspot. He can chat with other riders who are going to a similar destination to pool a rickshaw, or chat with everyone to report accidents and traffic. Next. The flow of the driver app. So here, what we are trying to do is visualize the data that we gather from the rider app in forms of hotspots and markers. The big green arrow represents a hotspot where there are two or more riders present in that area. The smaller green marker shows an individual rider with the location that he is going to. The driver can also chat with everyone in the global chat room, and he can choose to navigate to the hotspot or to the individual rider using Google Maps. Next. Carpooling and chat room. Here, as you can see, the destination that the user is traveling to is also shown in the text box. The user can join the chat room using a nickname, and he can talk with other people's who are traveling to a similar destination and pool a rickshaw. All users can also talk to each other, discussing traffic problems, roadblocks, or any other accidents. Next. We focus on privacy, and we do that by taking no user login credentials. And the only personal information that we take is the location and optional name and destination. And all of the code that is written is 100% open source. So the users can see what data is being gathered. Now I'd like Priyansh to explain the working of the app.
Thanks, Vinay. We use the Haversine formula to calculate the distance between the two markers. The Haversine formula determines the great circle distance, which is the minimum distance between the 2 points on a sphere, which in our case is Earth, given the longitudes λ1 and λ2 and latitudes phi1 and phi2 of the two markers, marker 1 and marker 2 respectively. The formula is as follows. So here, in this formula, R is the radius of the Earth, which is 6,317 kilometers. We can substitute the phi2 and phi1 values and the λ2 and the λ1 values. And using the formula Haversine of theta is equal to sine square of theta by 2, we get this formula. And by substituting the values, we get the Haversine distance between the two markers. Next. So to display hotspots in Driver's app, we used a clustering technique which uses k-dimensional trees and calculates the distance between the two markers and clusters according to their proximity. So like if there are two markers, it will measure the distance and it will cluster accordingly. When you're zooming around Google Maps, marker will cluster together when zoomed out and markers will uncluster when you zoom back in, based on which we have set our min zoom and max zoom in which the clustering will happen. If you have zoomed out below min zoom or if you zoomed in closer than max zoom, you won't get back any clusters. Next slide. So assuming we have 1 million active flavor users, we can use the data to recognize patterns and train machine learning algorithms to predict a more accurate number of riders at a given hotspot. This can potentially tell drivers a more realistic number of riders waiting in an area rather than only the ones who have manually marked their location. As a standard auto rickshaw has a capacity of only 3 riders, we must allow a sufficient number of drivers to navigate to that hotspot. We'll have an invisible UX which will dynamically show and hide hotspots based on the number of drivers navigating to the same place and the number of riders present in that area. In other words, if there are 4 people waiting in a hotspot, we'll need 2 auto rickshaws to pick them up, rather than having a dozen of auto rickshaws driving to the same location. Next. To conclude, I would like to say that our system will give a technological edge to local auto rickshaw drivers. And as more people start using Flavor, the process of finding rickshaws and carpooling with others will become much easier and more streamlined. The problem of mismanagement of auto rickshaw demand will also solve. In the long run, this will also improve traffic condition and reduce air pollution. Thank you. Yeah.
Thank you, Armil and Srav team. Am I audible?
Yes, sir.
So I think it's a wonderful presentation and that very useful for the auto rickshaw, that particular applications. So this is available. This is freely available, or this is paid applications for the auto rickshaw driver?
It's available in both App Store and Play Store. My teammates are not able to unmute themselves. Yes.
They are not able to.
Hello.
Yeah, Urmil and Vinay. Urmil also.
Vinay is unmuted already.
And Urmil?
Urmil, I think, is also unmuted. Once again, I have unmuted now. Urmil.
Yeah. Hi. Sorry. Thank you. So yes, both the applications are freely available for Android and iOS. The source code is 100% open source. And also as a service, currently there is no charge for riders or drivers. So the drivers, it's for the drivers, it's simply a visualization tool so that they can see and they know where there is a lot of demand. And there is no commission that they have to pay to us in order to use it. And for riders also, it's simply an enhancement. If they are waiting anyways for an auto rickshaw, then they might as well swipe and mark their location. You know, it's better than not doing anything.
So what is the registration process for the auto driver? Is there any registration process with you or something?
No, so we wanted to keep this app as simple as possible, especially for drivers. So for them, there is no registration process. All they have to do is simply open the app. They can choose the language which they want to use the app in, English, Hindi, or Marathi. And once they select that, they can instantly visualize all the markers and hotspots within 20 kilometers of their current location.
So, you know, security is the main issue. So are you thinking about to develop some or improve some applications to find out the behavior of the driver?
Yeah, sir.
Because behavior of the driver is very important.
Yes, absolutely. So we do have an SOS feature inbuilt in the rider app. So with the SOS feature, they can instantly call the emergency services if there is any kind of accident or something. And they can also call the RTO of Mumbai directly, so they can get in touch with them and can also send a photo of the auto rickshaw if they manage to capture one.
Okay. So who is managing those two applications, client and server? Your team or someone else?
Yeah, our team.
Yes,
all three.
Yes.
So you have all the data from driver as well as from the riders.
Yeah, the location. Yeah, which gets deleted in 15 minutes. Yeah.
And the location. Yeah.
And all the APIs, if I get to add, all the APIs are encrypted by GetCrypt. So all the API keys are under a security hold. So that data won't get out easily.
Yeah, sir. And the only information which we require from the user is its location. Also, the location gets deleted once the user starts moving and is outside the hotspots, or the markers anyway gets deleted after 15 minutes. And
so
putting
you don't have a history of the client driver and as well as
nothing.
The
No.
Okay. So there is no control and there is no history after the rating.
Nothing. Yeah, after 15 minutes, nothing. Yeah.
And the users can see the proof of this in the source code because it's open.
It's open source. It's hosted in
GitHub. Yeah. Okay. Thank you. Nice presentations.
Thank you so much.
Thank you so much.
Thank you, sir.
Thank you very much. And we will go ahead with the two presentations which are left. So first we are taking the paper Correlation Analysis of Demographic Factors on Low Birth Weight and Prediction Modeling Using Machine Learning Techniques, Borson. Nazmus Sakib Borson. So are you available?
Yes, sir.
Yeah.
Can you hear me?
Yeah. Please go ahead with your presentation. You can share your screen now.
Okay, actually, I'm sorry for the delay. I had some connection issues, so I couldn't
No problem.
join
No
on
problem.
time.
That's very fine with us. You can go ahead with that.
Thank you, sir. Give me a minute, please.
Yeah. And after this presentation, we are taking the last presentation from Moises Ecuador. So be ready, Moises.
Can you see my presentation?
Yes, we can. Go ahead, please.
So my topic is correlation analysis of demographic factors on low birth weight and prediction modeling using machine learning techniques. I'm Nazmul Saqib Boshan, and my respected supervisor is Dr. Rashidur M. Rahman, sir. So throughout the presentation, I'll be covering these points actually. So let's get started. Introduction. At first, we need to know what is low birth weight. So low birth weight is defined by the World Health Organization as a birth weight of an infant of 2,500 grams or less, regardless of gestational age. Low birth weight can usually develop PTB, growth retardation, or both, and may occur in premature newborns. Low birth weights are estimated to be between 15 to 20% of all births in the world, and in Bangladesh, approximately 22% of the newborn babies are born with low birth weight. Low birth weight actually increases 20 times higher risk of neonatal mortality, which is a big issue in developing countries like Bangladesh. Now, the objective of our project is to, we tried here to find the correlation between some demographic factors that actually drives the causes of giving birth to a low birth weight infant. We designed and compared prediction models to predict low birth weight depending on some demographic factors as attributes. This study will facilitate health professionals to understand the factors behind low birth weight, and this will help them while serving the community. So in the right side, we can see that we have considered these attributes for our, we have taken these attributes in consideration for our study. Data overview. Actually, the data set that we worked on is we got from the DHS program, which is a USAID supported project. In different developing countries, the DHS program is run, and they run a demographic and health survey to collect data from the rural and urban sections where they focus on different assessment indicators in population, health, and nutrition sectors. We have taken the data set of 2014 for a study. The final data set that we have worked on contains almost 4498 instances, and in total 10 attributes were taken in consideration. These are the attributes. The attributes are called current age in completed years, total number of children ever born, age of respondent at first birth, and so on. For the whole project, we have followed the CRISP DM methodology, which is cross-industry standard process for data mining projects. This methodology has 6 steps that we followed in our project, which is business understanding of data, data understanding, data preparation, modeling data, evaluation, and deployment. Data pre-processing. The data pre-processing was, there were 2 parts in data pre-processing. Actually, the data set was a huge, hello? Can you hear me? Hello?
Hello. Yes, you are audible. Please go ahead.
Okay. So actually the data pre-processing part was in two sections, which is feature selection and elimination, and the replacing null values and missing values. For the algorithm and modeling part, we have used logistic regression, naive Bayes algorithm, k-nearest neighbor, random forest, support vector machine, and multi-layer perceptron models. For the correlation part, we have used Pearson correlation coefficient to score these attributes. These are the visualization of correlation matrix. The left one is the correlation matrix, and the right one is the comparison of the correlations that we got from the study. Here we can see that most of the attributes are inversely correlated with the target class. Actually, only two attributes are positively correlated with the target variable. For the Pearson correlation coefficient, the range of the score is +1 to -1, where greater than 0 means the attribute is positively correlated with the target variable, and the less than 0 means the attribute is negatively correlated with the target variable. If the score is 0, then there is no linear correlation between the attributes. So we can see that these attributes are either positively correlated or negatively correlated, but no attributes are scored 0 in this study. Then for the prediction modeling, we have adopted two approaches. One is by splitting the data into training and testing, which is 75% and 25%, and another one is tenfold cross validation. Logistic regression and support vector machine performed out good for both of these approaches. Multi-layer perceptron also performed good in this study. Conclusion: the low birth weight is a leading cause of infant mortality. It is also a reason for obesity and diabetes, anxiety, depression, and increased leptin levels in adults in the long run. Sometimes low birth weight depends on some important factors that can be changed or manipulated by yourself. Like we can consider the early age marriage. Early age mother are likely to give birth to a child whose birth weight turns out to be comparatively low comparing to an average aged mother. So early age pregnancy is discouraged worldwide. We hope that this study will help the medical professionals as well as the researchers to understand the facts more deeply. It will also help the physicians to predict low birth weight before the birth of the child. Addressing demographic issues causing low birth weight, this work can be extended to evaluate other factors like food habits, maternal issues, antenatal care follow-up to correlate with low birth weight. Thank you.
Thank you, Barsant. Over to Dr. Singh.
Sakib, thank you for your presentation.
Thank you, sir.
So my question is, what about your sample size? Did you took sample size parents or the children's or the mothers or the fathers?
We have taken the samples from mothers. Actually, the whole data set is based on the.
I think for the 1,498 mothers.
Yes, sir.
Okay, and 10 different attributes that you considered for the mothers.
Yes, sir. Yes.
So I think the 4 attributes is correlated with correlated and that can be affected for the low weight or something. Yeah. So I can see the 5.
In this, yes, sir.
Yeah.
The higher attributes are highly correlated.
So what is your recommendations? So
actually, sir, this study, this is kind of a qualitative study actually. So we recommend
but this is quantitative. This is not qualitative. You already took some statistics. And you already
Yes, sir.
presented, and I saw the different statistics from different algorithm. And according to your study, I think the SVM and NLP is the best algorithm.
Yes, sir.
And yeah, so this gave the 81% accuracy or something.
Yes, sir. Actually,
So,
sir, this project was pulled over to facilitate the health professionals to understand this correlation, actually. So we can see that these attributes are negatively correlated with the low birth weight infants. So when a mother goes to a doctor or any health professionals, they can prescribe or suggest suggest them in consideration with their lifestyle or some demographic factors where they live. They can suggest accordingly. Actually, this is our goal of this project.
yeah, so I think mostly your attributes related to the body mass, weight, or some eating habits. Did you consider some psychological variables? Because psychology
No,
is also important thing for the study.
yes, but unfortunately, there was no psychological attributes. These are actually maternal and some demographic factors.
Okay, thank you for presentation.
So this was Barson from Bangladesh, and now moving on to the last presentation, we have Moises with us, and he will be presenting two papers, one after the other. So over to you, Moises. You are now unmuted. Go ahead to share your presentation. All the best. Are you able to share the presentation?
Moment, please. Good afternoon, everybody.
Great, go ahead. Moises, we are not able to hear your voice. Hello. No, we are not able to hear your voice. There is some issue with the microphone.
Hello.
Yes, now it's clear. Now it's clear.
My topic research impact of security apply to IoT in public organization in Latin America. Contains introduction, problem, a project, overall goal, material and methods, result, discussion, future work, and conclusion. Introduction, Internet of Things, IoT, derives the connection and communication between devices interoperability and certainly intelligent infrastructure in the included areas such as home, agriculture, health, transportation, and other services. The impact of IoT in social and economic use the data in the database and the information in delivery through services or programs. Problem a project, the followings I consider critical system, telecommunication, water service, electric power service, transport service, rail services, transport, public safety service, and the health service. On the other problem is the group in the delivering and reception of information from citizens through the base the general rules amongst data IoT or public organization. Overall, the objective is to determine the impact of security applied IoT in public organization in Latin America. Material, summary purpose on IoT, reference, reference import precision 97.7%, reference 14 98%. Next, we need a tracks of the IoT domains. One, alternative that or services attracts according to time, directory on the nodes result exhausted, multiplication on model Y-MINE identification or the domains on internal attracts virtual Arthur physical. Second, Daniel or servicio false identity silicon. 3. Information lakes, DOC, data traffic physical arrays. 4. Activity device scan internal loss of control, DOC, device key extraction command insertion. Methods. The principle of revising the design according to our 1. Present privacy. 2. Privacy entirely into in design. 3. Security from source station. Consideration user privacy. Scope the proposal. Design security model applying IoT for public organization. The proposal is the public organization or government companies in Latin America that provide services to citizens and suppliers, adopt a 4-layer architecture applying in the shown in the table 2. See, layer, 3-layer, name each layer, sensing network application, perception network application, perception transportation application, reception network service, 4-layer, sensing network service interface, perception network support appliance, 5-layer, my data acquisition, accession game, internet mainland appliance, perception network mainland application business. Result. Impact of security applying IoT in public organization in Latin America. The Committee of Security in Latin America is developed 0.717 Brazil and Uruguay and between 0.16 and 0.17. That's a change. Year, the national strategies, Colombia demands on average 0.15A, Paraguay improves in 2015A. Ecuador is between 0.35 and 0.47. We are improving strategy. In figure and country different. The comment in the security in the North America, in the by United States, begin groups under percentage radius in the between 0.182 and 0.966 each year. They improving their national strategic application of cyber security. Canada indices are between 0.79 and 0.89. Mexico indices in the between 0.32 and 0.63. That is the improving their security strategy on the Caribbean territory. In the different country evaluate. Architecture, prototype, and security applying IoT in the public organization Latino America. show the IT of infrastructure here cybersecurity in the applying in the science on the child layer have level of security environment or public organization in the country level. All organizations are working in the shared data blockchain. Figure project, si detecto, respond, recover, identification y lo que es 3-layer service, 4-layer application, first layer data, first layer section, second layer network. The figure 6 algorithm efficient. I show the simulation in the scenario on the first in the 3 rows. The first group is the sensor device layer. The second rows, the service process interface report index metric of the network. Service and applied layer, the trees and ground which brings the respective layer here, the data structure and function in the smart contract. For a first scenario, 273 device, 8 sensor, 19A structure, 35 smart contract function, 10 protocol and 5 layer result in the 85.37% algorithm efficient. In the scenario there is 87.96%. On the way scenario there is 940.76%. For the last scenario in the 6.43 point efficient. Difference percent and graph and picture, see, 20 moment please. 18643. Discussion. Principal in the result in the architecture protectiva is cabling the HR layer, the number in the smart device, single result services application, and the six in the data house in the supported by the protocol and standard ad hoc. Communication is security from device communication to the cloud. Future world. A future world, a security project in IoT domain switch blockchain was proposed for public organization in the Latin America. Conclusion. One, it was conclusion that the proposed architecture and algorithm apply cybersecurity to the IoT domains of implementation the level of information protection through the proprietary protocol and standard. The algorithm protocol simulation is between 87.96% and 97.28% efficient. Government must advance national security strategy to minimize vulnerability, risk, and threats, and the inherent factor in information. 3. There is no single solution for all Latin America countries. Each country most general opportunity and economies amongst the government, public, authorization, university, sociedad, and international organization. Thank you.
Hello.
Hello.
So Dharam sir, questions too.
Yeah, thank you, Igundo Moeshish. So nice presentations, and you have presented the impact of cybersecurity for the IoT devices. But I didn't see any architecture or algorithm in your presentation.
An architectura de security in paper no in presentation, architecture global the security information.
So did you use some simulator or some existing algorithm for this one, or what algorithm you used for your research?
Sí, and the algorithm no in presentation. ¿Sí?
Yeah. Okay. So what algorithm did you implement it in some programming language, or you use some existing simulators for your work, research work?
No implementation is one of
So this
one
is a
alternativa de security implementation in the future.
Okay.
¿Sí?
Okay. Thank you, Moises. Thank you.
Next.
Now you want to present
Please.
next paper?
Sí. Second paper, moment please. Second paper, prototype and perform RN in social network to determine cyberbullying. Contenida introduction, problem and project, overall, material and methods, result, discussion, future work and conclusion. Introduction, we 2.0 a young people in the connection through social network to the maze in the added conclusion, multimedia, content, virtual communication. For this reason, in the problem in general, the privacy, intellectual property, or your security, personal data protection, cyberbullying, intimidation, of others. Problem a project. There are several problems, and it is a project that is contribution on the intruder's detection on network or should have intimidation, stalking, cyberbullying, and the other attracts the information in the from social engineering, such as publishing, among the common problem in literature, lexico or kernel. Overall, the objective of the reason is the developing a prototype to perform arrangements on social network to determine cyberbullying. Material, the efficacy of several proposals was considered, see, reference for presentation more important, see. 1, 2, 3, 4, 5. Reference second, material, difference, investigation, in efficiency, 78.5% accepted by 89.40 accepted for student. Reference 3, survey data in efficiency, 74.5% are victims of cyberbullying. Reference 4, algorithm test, 97.27% acquiring. Is reference 5 in efficient data test, 18.5%, 12 and 2% the highest, medium, and high the classification respectively. More reference method and methods adopted, formulas, scoped for the people prototype are elements in social network. On this occasion, we go to arrange elements in social network. This arrange social network arrange process data analysis, control institution, participation in taste, current characterization. They aren't trees on point of the range on the events or currents and the mates. They receive network recommendation on the time interpretation in the order to have a certain level or standard. If the all collation information verification text analysis sugerencia and evidence in the qualificative way, the operation the I carry out in the order or the as the situation, the authentication, validation, and acquiring of the data. Result. This architecture prototype to perform arrange on social network to determine service budget, level, see, level, channel, capacity, user, see, people post, or survey, fan, still, en capacity, post, contenido, precario, activities, volume, contenido, complex, verbal, device, different, technology, incapacidad, international, internet connection, security protocols. Social network, different network social connection, people social connection for work. R&D data analysis, database analysis in this report, classification different analysis metric, prepare, report, communicate. Organization, entity, governmental control, and layer, capacity, control, preventive, judicial process to intervene, risk, or live. Figure 5 service level architecture, prototype, description, so the simulation for the architecture in the layer 1, 2 in the contrast, comply the and device in layer 3, 5 in contains in tools in the report in the layer 4 is contains the database detector of processes in the more tool the report the architecture has the service level or the architecture describing the multiple report in the most general level of service implemented for. View figure 5 different percentage. Figure 7 performance or algorithm prototype. And presentation simulation in the paper in algorithm design. 5.7 allow the performance on the average on social network to determine cyberbullying in the fast present the data on the social network are the metrics user and still the fluent representant on the complaints and comments. In the free social network, the performance is 94.59% on the 140 units, the social network data set 81 United set compliance compared to the social network say the percentage is the 92 31% con 121 United School Social social network and data set and the 19 United States on compliance. Commented in the social network, the performance is the 94.39% with 195 United Social Network data set and 109 United States compliance commit. It was deduced the porcentaje de algoritmo prototipo basada en dataset social network de simulación obtenida the average es de 90.8%, ¿sí? Promedio. Discussion, relation or result, the architecture prototype and the algorithm prototype are related through on the components, the food prototype for the layer user the being and the harnesses are analyzed by the algorithm from the device layer that general that or social network that or the social media layer is analyzing the algorithm from the RNA layer are the process that the algorithm is a tool for the analysis for the organization layer. The authorities request the performance on the RNA algorithm. Algorithm design in the no presentation in the paper. And future work. As future work, we proposed a model the information security for RNAs on the social network to determine service bullying in an intermediate way. Conclusion one is what conclusion in the algorithm prototype obtain valid information from social network in the layer in the precise weight trunks in the classification and wins on the office text. The prototype obtained 93.18% the average performance. The prototype for as a foreign tool as the can hold government against in the process and explorer share and the determinations cyberbullying in the developing on the their activity in the form of expression. 3. Conclusion, research enhances the focus in the level collection analysis and process of text analysis on the classification on images and videos, auditory, trends, show the encoding in the order on the organization in the necessary tools and expedient the process of cyberbullying. Thank you.
Thank you, Moises. I'm audible, Moises, for you?
Well, for you.
Hello?
Hello.
Yes, sir, you are audible. Please go ahead.
Okay, Moises, is there any rule or regulation in America regarding the cyberbullying? Because you know the rules and regulation is very, very important. Do you have any existing rules?
In the America ruler integration for the cyberbullying, in special in Ecuador, no determined specific layer. Ecuador, in Ecuador, problem en marco layer for execution cybersecurity with efficiency.
Okay, thank you. Thank you for your presentations.
Thank you.
Thank you very much.
Thank you.
Moises. Thank you very much, Moises. And Once again, I thank all the presenters for presenting their valuable contributions in this session. And it is very unfortunate that this session was organized digitally. Otherwise, we would have loved to organize it physically. But unfortunately, the pandemic has changed the scenarios in the world. And I once again believe and I am hopeful that this COVID-19 will soon be a thing of past and we will overcome the situation and again we will meet for our future conferences. My thanks is due to Dr. Dharam Singh who has chaired this session and I understand that chairing a session in a physical conference is much easier than chairing a session in a digital conference because you need to stick to a single screen for more than 100 minutes and then listening to all the presentations, commenting on their work and questioning them. So I appreciate his efforts for sparing his time and I ask Richard to kindly share a token of appreciation to Dr. Dharam Singh using this new digital mode. So thank you very much, Dr. Singh, and we would appreciate your support and your collaborations in future as well. Thank you very much.
Thank you. Thank you for you and your team. Thank you.
There are two more things which I wish to convey to the authors that as this is an IEEE conference, we have already started the copywriting process of e-copywriting process for IEEE. Many of you must have received the emails of e-copywriting and many of you must be receiving it in next 1 or 2 days. So I request you to sign these copyrights as soon as you receive the mail so that we should not delay the proceedings more. The cycle time for this publication would be around 2 to 3 months depending upon the response from IEEE, but an average time is around 2 to 3. Maybe it's less than 2 months, maybe it's slightly more than 3 months. So till that time it is published, please be patient. If there are any queries in the meanwhile or any questions asked from IEEE regarding the content or there are any other content issues, we will definitely let the authors know of the concerned paper. Lastly, I would like to say that you will also receive your presentation certificates, your thank you letter, and the payment receipt which you have made over the mail just after the session is over. So I wish you all a safe time and look forward to see you all in WS4 2021 physically in London. Once again, thank you, Dr. Dharam Singh, for joining us for this session and sparing your valuable time. Thank you very much.
Thank you.
Thank you. I think 1 more minute session is open up and then we will close the session. So if you want to exchange any email IDs or anything, you are most welcome to do that. Thank you.